Okay, well, welcome to the January 9th, 2024 session of Clementine SDR and Ham Sci Technical Session. My name is Dave, KV0S, and this week I've been working on radios and reorganizing my shack and setting up different pieces of things. So it's kind of the annual move it around and try to clean up the wires a little bit. So that's where I am now. Next on the list, we have Nathaniel, W2NAF. Go ahead, Nathaniel.
Thanks, Steve. Let's see. So this week, I've been giving a number of presentations. I gave a presentation to the Marple Newtown Amateur Radio Club last Thursday night about ham sci, and then that was virtual. And then I gave an in-person talk in Long Island, at the Ham Radio University about ham sci and the eclipses. And then I'm going to be giving that same talk to the Frankfurt Radio Club, the FRC, virtually this coming Tuesday night. And today it was less about the ham site project, more about ham radio in general. The local Lackawanna County Blind Association called me and asked for they said some of their people were interested in amateur radio and asked if I could come down. So I went down there, but I found three blind hams I knew that were able to come in over Zoom. And so we had a really nice discussion for about an hour and a half with the Blind Association members about ham radio with some actual blind hams. So that was all really nice. I've also been continuing to work on this paper about traveling on spheric disturbances. So I've been doing a lot with trying to get the manuscript is coming along. I've been making some edits to that. And then I've also been working on the let's see, on this other figure, a redo of a ray trace figure. So I've been using the International Reference Ionosphere for that. Been trying to get the HamSci workshop up and going as well. So I think the abstract page is actually open. I think we should probably start advertising that soon. And I think that's pretty much it. There's a few other things here and there, making sure all of my grape systems and things like that are working. And I think they are again. So W2NF, back to net.
And just a clarification, HamSci this year will be in Scranton?
No, it's going to be in Cleveland at Case Western Reserve University. And so the information is up on the website. So if you go to hamsci.org/hamsci 2024, you can read all of the information.
Okay, thank you.
Yeah, you're welcome.
Next on the list is Dave, KD0EAG. Go ahead, Dave.
Well, hello. I'm not sure what I've been up to this week, but I've been working on the stuff for the Grape 2 folks, and putting together another rack, and I don't remember, but that's it for me.
Okay. Next on the list is Michael, AAK. Go ahead, Michael.
Oh, thanks very much. Greetings to everyone listening. Back to you, Dave.
Okay. And next on the list is David, N1HAC. Go ahead, David.
Good evening, everyone. Biggest deal around here is we just got snow. Probably our second good size snow in the whole season. And then it's going to rain on Tuesday. Yeah. So, we're continuing to work on our AM Doppler project. I actually had to repair a GPSDO. The ovenized oscillator failed in one of them. Um, we're working out, shaking out the units that we already have. We're building more. We're supposed to deploy between 12 and 15 of them, hopefully before the eclipse, so that we can be complementary to all the other things going on. And I'm a little bit distracted this evening. I'm watching the Michigan Washington game. Go Blue. Back to net.
Okay. Next on the list, we have Johnson Francis, VU2JO. Go ahead.
Good evening, everyone. It's good morning here. I just wanted to join to hear something or learn something. I'm a new member of the Hamsay group. So, present good morning to, or rather good evening to each and every one of you.
Very good. Welcome. Next on the list is Franco, K4VZ. Go ahead, Franco.
Hey, good evening, everyone. Happy New Year, everyone, since it's the first time of the new year that we get together. Over the last 2 weeks, I worked on a few things. First of all, I got this TRX Duo, which is the Red Pitaya clone from China. I've been playing with that, working with U-Boot, making it run all those Pavel Demings examples and so on. So a lot of experience there and starting to learn about FPGA and Vivado. So this should be a good thing to practice with. And then I've been working back and forth with Rob Robinet to try to get those grape files down to 10 sample per second, and then maybe we can discuss later on with Nathaniel if we need a different sample rate, in the future. And then that's about it for me. Back to you, Dave.
Well, very good, Franco. As you work on that other, I have a couple original Red Pitayas. I'd be interested in trying anything.
Yeah, we can talk about that later. Yeah,
Yes.
there's some good stuff there.
That's been a very good radio for me. I ran that as a whisper for 2 or 3 years before the RX888 came along.
Yeah.
So,
I want to see if I can run a mini K9Q radio in there and then make it connect to the. I will discuss it.
yeah, very good. Next on the list would be Michael, AC0G. Go ahead, Michael.
Good evening, everybody. Well, I outlined already some of the travails I had up in Fargo, but at least I got the magnetometer up and running. I still need to coordinate with Bill Engelke about uploading that to the University of Birmingham source. And I am eager to get learn what Franco comes up with on defining the data format out of the 888 for listening to WWV. That'd be cool.
Yes.
Back to net.
Okay, and let's see. Next on the list is Tom, N5EG. Go ahead, Tom.
Oh, good evening, Dave, everyone in the group. I've been playing with the KA9Q radio. I've got the Whisper Demon decode working, which seems to work real well, and it decodes all the bands. I have started making another video on playing with that, and it looked good until I forgot to magnify the command line window for running decode, and so while the audio is good, you can't see anything on the screen. So time to reshoot that and go. Working on a couple other odds and ends and cleaning up the shack. Need to clean up the shack once every 10 years, whether it needs it or not. Back to the group.
Yes. I had 2 questions that you might be able to answer for me. So I'm going to ask you right now.
Okay.
I find it unclear. Right now, I'm running Radio D, only 1 instance per computer. Have you
Okay.
run multiple Radio Ds on a single computer and keep them?
No, I have not.
Has anybody else? Okay.
I have.
Dave, I don't understand. Why would you run multiple? Do you have multiple RX-888s to the same computer?
No, I'm running those, and I'm also running VHF uh, K9Qs as well to
Yeah,
listen
I've
to
run
local
I've
traffic.
I've run an air spy with a
Yeah.
888 on the same machine. You're using two instances of Radio D,
Okay,
just
and
pointing at a different config file.
I tried
It works.
running one where I was trying to also listen to the NOAA weather, and the NOAA weather seemed to conflict with my 2-meter. So I don't know if I did something wrong or what, but I just wanted to make sure if it was possible, if I was just being foolish. So that was one question. And the other one that I was, I forgot about it, but I did want to mention, Tom, did you bring your presentation for tonight?
Yes, I've got it on this computer.
Okay, very good. Tom has put together a little presentation on high-speed in-house network stuff. So I have one last person. Jay showed up. WB8 SBI. Jay, you want any comments?
No, I just missed everything that came before I jumped in. So I'm assuming that if there was something that I need to know about, somebody would tell me. Other than that, I hope everybody had a good holiday season and looking forward to a good year. And now I'm just getting myself organized. I'll be down in the Akron, Cleveland, Ohio area for the eclipse. And it's my intention to be on 20 meters FT8 or FT4. Plan A is to be monitoring before, during, and after the eclipse, and to set up FT8 to make as many contacts as I can. But I'll also have an internet connection so that whatever my station hears on 20 meters will get updated to PSK reporter in real time. So that's plan A. Hopefully I get to do it in a park where there's not only power, but I have my friend's 20-meter buddy pole antenna to be able to set that up, and then already have my solar eclipse glasses there so I can safely look directly at the sun because they're the same ones I used for the last solar eclipse down in Kentucky. But hopefully I'll be right on the center line to see it. By the way, does anyone know when the next solar eclipse that passes over North America would be? I haven't looked it up. Anybody know about when
Somewhere.
that'll be?
2044.
Say again?
2044, 44, 20 years from now.
Ah, okay. So in
It'll
other
be a
words,
while.
well, I'm not too sure. Yeah, see now, not too sure about my being able to participate. So got to make the most of this one.
Yep.
Otherwise, that's about all I have. So back to net control.
There are also other ones in other parts of the world you can
And that 2044 one, the path is mostly over Canada and then
Yes.
goes into Greenland. It just very briefly grazes the northern part of the United States.
So we've been lucky to have several here in the last 10 years.
Yes.
So anyway, so that brings us to the end of the list. And so Nathaniel, did you have anything, or should we just let Tom give his talk?
I think we could just let Tom give his talk, and then After that, I might be interested in talking with Franco to hear more about how things are progressing with the Doppler recording mode on the Whisper demo, which I think he's been working on. So, but yeah, let's go ahead and start with Tom.
Okay, can you see my slides?
Yes.
Okay, so this was something, there's been a lot of conversation about high-speed networking and 10 gigabit Ethernet networking on the list over the last few months. And I was thinking maybe we could go briefly over 10 gig E a little bit. It's just slightly different than Ethernet at slower speeds. So currently, if we have a radio with 125 megahertz A to D, 16-bit, that requires about 2 gigabits per second link speed and some overhead if you add framing and TCP IP headers, things like that. If you have a dual channel radio, it can produce 4 gigabits per second. And so we're getting to the point that in some cases, I think faster links than gigabit Ethernet are useful. And 10 gigabit Ethernet is really coming down in price quite a bit, and it's increasing in availability a lot. In the last 2 years, it's really declined a lot in price, and you're starting to see it on a lot of consumer equipment now. There's 2 form factors generally used in 10 gigabit Ethernet. The one we're all familiar with, the RJ45, 8-position twisted pair copper cable connector, and that's used on Cat 6A cable at 10 gig. And the other form factor is called SFP Plus, which is small form factor pluggable, and SFP runs at 1 gig, SFP Plus runs at 10. There are SFP Plus modules available for all fiber and all copper formats. And so it's actually fairly flexible, but it's just a little bit different than what we're used to using. We find out that the form factor affects cost, it affects power, and it affects the latency of the connection. And of course, just recently, 2.5 gigabit Ethernet over RJ45 has become widely available. And it turns out it's pretty closely related to 10 gigabit Ethernet. The IEEE 802.3 committee writes the Ethernet standards. I was a member of that committee for, about 7, 8, 9 years and wrote some of the, participated in writing of some of the standards on it. For 10 gig, it specifies 3 different physical interfaces. 10G base T, which is twisted pair. And the objectives for that is category 6A cable up to 100 meters. And you'll find that a lot of the modules don't quite actually reach 100 meters. You'll find 30 meter and 80 meter modules also common in addition to a few at 100. And category 6 cable can be used up to about 55 meters at 10 gig. Then there's 10G base SR, SR standing for short reach, and that's a multi-mode fiber interface. The 2 kind of fibers commonly used, OM2 fiber supports about 82 meters at 10 gig, and OM3 fiber supports 300 meters. And then there's 10G base LR, or long reach, which is over single mode fiber, and SMF reach objective is 10 kilometers. There's a bunch of other specialized optical interfaces as well. Won't find them in your local area network very often, but there are 10G base standard, or not standards, but modules that will go out to even up to 80 kilometers. There's also SFP modules that will work with GPON, which is the gigabit passive optical networking. And some of the internet service providers actually provide GPON plugs into their home equipment. And so there's a few companies now that produce equipment where you can just plug the GPON module right into your home equipment and put gigabit or 2 or 3 gigabit Ethernet in a module right into your own home equipment. So if we look at some of the copper modules, the module on the upper right is a PCIe module. This one's got a by-4 connector. And in this module, there's one card cage, which is an SFP plus card cage, where you can plug in a module. This module is obviously made to be a 1 or a 2 10 gig interface. They typically run in the $43 to $58 price range with an SFP interface. They also make SFP plus to 45 RJ45 modules. That's in the bottom right there. And so you can actually slot one of those modules into the card just above it, and that will give you an RJ45 interface on that PCIe module. The modules I can find, typically the 30-meter reach over Cat6 cable, it's about a $45 module, and the 80-meter reach one is typically about a $90 module. This is pricing that I got from Amazon last month. Another common interconnect is what's called a DAC cable, direct attached copper. It's a passive cable, and it's used typically up to about 5 meters. I think there may be some ones slightly longer using higher grade cable. But pricing a 1/2 meter cable, which is typically used to connect 2 switches or a switch and a router at 10 gig in the same rack, is maybe about $8. And a 5-meter cable you can find for about $20. The module on the lower right uses the SFP plug-in on each end. The cable is hard attached, so the cable doesn't physically disconnect from the module. It's hard attached to it. And you can see it's pretty simple. The schematic of the setup is on the upper right. It's passive. It just capacitor couples the data lines. They're differential and individually shielded. So the transmit and receive are individually shielded. Fiber modules look very similar. In the upper right is a multi-mode module. And I found you can buy a pair of them for $25 on Amazon. So that'll get you up to about 300 meters with OM3. And at $12.50 per module, they're pretty cost effective compared to RJ45s. And then the one below is the single mode fiber module. And I found them down at $19, which is pretty amazing to be able to get single mode fiber interconnect in such a low cost package. Fiber types, the orange fiber in the upper right is an OM2 fiber. The one in the middle, the teal colored, is an OM3 fiber, and the one at the bottom, a single mode fiber, is a yellow jacket. And I found pricing for OM2 at about $48 for a 60-meter pre-terminated cable. OM3 about $43. You can see the volume on OM3 is quite a bit higher, and SMF about $48 for 60-meter. It uses what's called a duplex LC connector, and that's 2 optical connectors that are joined so that they only plug in the right way into the module. So on all of these, they have a dust cap, 2 dust caps. You got to pull the dust caps off. You got to pull the dust cap off of the SFP plus module, and then you click the fiber in and connect up the fiber to the modules that we see on this slide. So these modules, you can see where they plug in. These modules typically also come shipped with dust caps that you remove when you use them. Switches, RJ45 and SFP plus base switches, routers, interface cards are all available. You typically find that the RJ45 modules and switches are more expensive than the SFP plus modules. So the switch in the upper right here is a 4-port 10G using 4 SFP plus cages. When it was introduced, it was $99. Price has gone up to about $150. The one in the bottom's an 8-port RJ45. It's about $475. I found an 8-port SFP plus switch, and it was about $275. One thing to note, the switch in the upper right, you can't fill all 4 of those SFP slots with the RJ45 modules because they consume too much power. The switch gets too hot, and it in fact doesn't have enough DC power to supply for RJ45 modules. So you have to be a little bit concerned about that. 10G base T characteristics using Cat6A or Cat6 cable. The module has an interface latency of between 2 and 4 microseconds. At 10G, that's an entire 1500 byte packet in latency going through the module. The power dissipation's about 2.5 to 4 watts, so they get pretty warm. The problem is that the bandwidth of Cat6 and Cat6A cable is really quite a bit less than what's needed to send 10 gigabits down the copper cable. And so there's a lot of magic that has to happen in the digital signal processing to get the signals onto the cable. So what happens is they use 4 pairs in the cable, and all 4 pairs are full duplex. So 2.5 gigabits per second bidirectional on each of the 4 pairs. To reduce the symbol rate, the symbols are first LDPC encoded, which is low density parity check. So they add forward error correction to the bits. Then they're sent as 2 PAM16 signals. This is 1 of 16 amplitude levels on the pair. And then 2 of them are sent. So you get 4 bits in one symbol, 4 bits in the next. Turns out you only use 7 of those 8 bits. They then do what's called pre-emphasis on the transmitter to peak up the high frequency components to compensate for the frequency roll-off of the twisted pair. And then they implement trellis coding, which gives you about 3 dB signal to noise ratio improvement. So there's a lot of really sophisticated DSP going on to make this work. Again, Cat6 is rated about 55 meters at 10 gig. 6A has a little better bandwidth. It's rated at 100 meters. 2.5 gigabit Ethernet uses the exact same mechanism. It just runs at 1/4 the symbol rate that 10 gig works on. So it's become lower cost, it's wider, more widely available, and 2.5 gig Ethernet works on Cat5e cable up to 100 meters. So if we look at the table here, the symbol rate for 2.5 gig is 200 megabaud, which is per lane, and the bandwidth is about 100 megahertz. And so that easily matches Cat5e cable. When you go up to 10 gigabit, the symbol rate is 800 megabaud, so the bandwidth is about 400 megahertz. And that's really kind of pushing the limits on what category 6 cable can do. And so Cat6A has a little bit better frequency response than Cat6. So in data centers, you rarely see the RJ45s used because the cost is quite a bit higher than an SFP. The latency is a lot higher than an SFP. And of course, the power dissipation is quite a bit higher. So SFP plus form factor is very common at 10G base T. I use mostly SFP around my ham shack, connecting routers to switches. I do use one RJ45. One of my servers has a 10 gig interface that's an RJ45. And so I'm going through a short jumper cable, Cat6, between the server and the switch with the 10 gig interface. Computers, a lot of single board computers now are available with 2.5 gigabit Ethernet. A lot of switches are available. There's a slight cost premium over 1 gig, but it's not much and it's coming down. So 2.5 gigabit Ethernet's getting very popular. 10 gig is starting to show up on fairly low cost computers. I found several that have multiple 10 gig interfaces. And I've seen, if you've seen a Zima board, it's about $100, $150 small form factor computer with a PCIe connector on it. And you can plug in one of those 10 gig to PCIe adapter cards, and it does work. I've also seen a demonstration of a Raspberry Pi 5, which has a PCIe ribbon connector on the Raspberry Pi module, and you can make an adapter that provides a PCIe connector and a ribbon cable to connect to that slot, and plug in a 10 gigabit Ethernet module to that. The Raspberry Pi officially supports PCIe Gen 2 by 1 lane wide, but there's a number of folks who've gotten them to work at PCIe Gen 3 by 1 lane. In fact, there's a ham in St. Louis, Jeff Geerling, who has a Raspberry Pi 5 talking at 10 gigabit Ethernet on his YouTube channel. He's got a great YouTube channel if you haven't seen it. And then, of course, there's a bunch of others that are pricey and kind of specialized. Larger form factor PCs have been available with native 10 gigabit Ethernet interfaces for a long time. So they're readily available and they're actually not very expensive, especially if they use SFP plus slots. And then, of course, you can put PCIe add-in cards. And generally, I find that the SFP plus card is about half the price of an RJ45 type of PCIe card. Note that PCIe 3 by 1 lane is a 0.985 gigabyte per second interface. And so that's about 7.88 gigabits per second. So if you use a 1X PCIe 3 socket, you're not going to get quite full throughput at 10 gig, but you'll get close to 8. So that's not too bad. So it's becoming widely available, and even low-cost, small form factor computers are starting to show up with it. So that's what I have for the presentation. Dave?
That's very interesting.
Yeah, thank you, Tom. That was very helpful for me.
Questions?
It's amazing how cheap they've got.
Yes.
This will be useful when I hopefully have some discussions with the university about hopefully upgrading my network situation.
There you go.
Very good.
How does
So
this
how long have you wired your shack? You got your shack wired with SPF plus then?
Yeah, I use DAC cables as interconnects in the network rack. And then I've got some RJ45s going. The server's not in the rack, so I have a couple of Cat 6 cables that connect the server over to the network rack.
What do you use the extra bandwidth for primarily?
There's a couple of things I'm running. I have some jobs on the server where I go way past 1 gig on the input to the server. So if I'm doing backups, I'll generally kick off backups on all the computers in the house, and that quickly blows away a 1 gig interface. And so it's well beyond that. And I've got 1 or 2 apps, video streaming apps. If you like to edit videos, it's very nice to be able to do your video editing on a client that's connected to the file storage at 10 gig, because you can do the editing right on the storage server in real time, and it's not sluggish at all.
That's really nice. Do you have any
Hey, Tom, how
SDR
the-
applications that you're using this for yet?
Not yet. As you know, as Phil has mentioned, the hard part of the SDR is getting the bits out of the ADC. And so, you know, if there's a way to get them out to either PCIe or to some other interface, you know, it would be nice to be able to swallow all the bits out of the ADCs at the speed that it can generate them.
Hey, Tom, how does 10 gigabit Ethernet compare to USB 3.2 generation 2? I mean, from pros and cons.
Well, the Ethernet, of course, is, you know, you can reach multi-hundreds meters distance, and that's really difficult to do on USB. and it's a network protocol, so you can switch it and you can route it, you can address it, you can talk to servers. So I think it kind of maybe is a little bit different of a job than what USB 3 does.
David.
So the output though, if you were going to be, harking back to Dave Larson's question, if you're running an RX 888 and you're really using a whole 128 megahertz and you are making that available on your local area network to clients on different computers, this is where
Mhm.
something like this would really come in. I know that when I put TTL, set it to 1 on KA9Q radio, it just shuts down a local network that is 10, whether it's not 1 gig, and even that
Right.
it stresses it. So
Yeah.
if anybody
Well,
was going to
K9,
run computer to computer streaming like that, it's got to have that higher bandwidth.
yeah, KE9Q does a really great job of, finding and slicing out just the bits that you are interested in, but all that work is done on the host that the KE9Q is plugged into. And, so you can see applications where if that was a very powerful host that had a KE9Q radio plugged in, that very powerful host could in turn stream a lot of the bandwidth of the radio out over the network interface. So there might be applications where that's fairly useful.
Well, Michael, I only wanted to mention quick that that if you set TTL to 1, it should send the packets to the multicast group on your switch if your switch has speaks IGMP snooping, and any traffic should actually be connecting to the multicast group inside the switch, living in the switch, and not necessarily connecting to the host running KA9Q radio, unless there's some sort of feature that allows that to happen inside the Pi. But from my understanding, any bandwidth, any that all traffic technically will only go through your switch and not to KA9Q radio if you have it sending to a multicast group. But I could be wrong.
Well, I started using K9Q before Phil wrapped up the Radio D inside, or the front ends, the radio front ends inside Radio D, number 1, and before I had a snooping switch. So I experienced the hardware, just having this thing flood packets all over my network and shut everything down. And my wife hollering at me, "What the hell happened to the Ethernet?" And so, and my kids too, who of course want to be listening to all their stuff. So, yeah, when he rolled the front ends into Radio D, that helped a great deal. And then when I followed the proper instructions and got a switch that did IGMP snooping, then that also helped a great deal. And I also learned that I had to, if I've got 2 computers, I plug them into sort of a dumb hub and have the switch separate from that, so that they can talk to each other in that little subnet, and then the switch blocks it from going everywhere else.
Right. Yeah. That's also a another thing that I forgot to mention. Yeah. If your switch doesn't speak that, then the whole switch is going to be flooded, and everything's just going to be shut down, because I ran into that issue many years ago when I first started getting into multicast. I was thinking, well, geez, what's going on? looks like it's broadcasting to every port of the switch, but in a regular switch that doesn't speak IGMP, um, that's 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 what'll happen since it's a broadcast address. It'll technically broadcast all over the place. I personally use Cisco switches, but there are other switches now, Netgear and other sorts of smart switches, which you could use, which are a little cheaper than Cisco switches and easier to configure. But yeah, that's yeah, I've also run into that problem too. It'll take the whole network down um, if you don't have the proper switch.
What does it mean when they say snooping? What's the phrase? I hear it all the time, but
What it means is that there is a protocol in multicast for clients to indicate that they want to listen to a multicast stream. And so the multicast sender will advertise that they have a multicast stream, and the listener will say, I want to join the multicast stream. Or when the listener goes away, I want to disconnect from the multicast stream. What the snoop does is the switch watches the joins and the leaves. And if it sees that a client on port 3 has joined the multicast group, then it will forward multicast packets out that port 3. And then if the client on port 3 disconnects, it will stop forwarding those packets. And so it limits, it's kind of a violation of the 7-layer model, in that the switch at layer 2 is kind of snooping up into the layer 4 protocol to see what's going on. And it just does it to prune traffic from non-subscribed ports on the switch.
that's a bit of jargon that I never quite understood. I kind of had a sense what it was doing, but I could only guess. There's a lot of that in all this.
Even a lot of switches that are snooping capable do not come with snooping enabled. And in fact, many of them, including many from Cisco, don't even provide a GUI interface into the enabling and configuring the IGMP snooping features. So they're really not useful unless you know how to go in and on the command line and configure those switches through the command line interface. So I have been, I would like to encourage Phil to consider providing an alternative interface into Radio D than the multicast. It is a bear to debug, and it also involves adding a multicast DNS service, so that you now have to not only have IGMP enabled switches, but you also have to have a multicast DNS service running with its own set of new things to learn and configuration errors that can happen and so on. So it would be, since almost all of the installations that that I think this group and users like us are going to run one 888 sitting on the same computer, and it would be so much easier just to have a list of ports and have a client connect to a local host port and get a stream of things from it. It would just dramatically simplify the configuration and deployment of systems. But
what wasn't Phil's objective when he did this? He was teaching engineering students about networking.
yeah, well, it's a wonderful feature. I think it is really elegant, the implementation and the use of multicast. I mean, my professional life and my success in my as an entrepreneur was based upon multicast transmission of video, professional quality video. So I'm it's not that I object to it at all. It's just that it really introduces a whole new set of challenges, especially for home users and remote sites and simple installations that I think are the benefits. Those sites don't benefit from the capabilities of multicast, but they incur all of the costs, both and it's not it's I burned all of much of Sunday afternoon thinking I had a multicast routing problem over at Bill Engelke's site, and it wasn't, but I've had so much trouble with multicasting. That's where I went first, and turned out it was other issues. So has Bill shown up? Was he in this meeting? I got an email from him that they have a bad windstorm and the power is going in and out. So he made it.
And Bill has been dedicating Monday nights to, I think, choir rehearsals.
Oh, okay. Okay. Well,
So he's been showing up to Thursday meetings and Tuesday morning meetings, but
okay.
The subject of MDNS is something I'd like to ask someone who a little bit more about as well.
Multicasting, yeah.
Yeah, I'm aware this stuff's descended from like Bonjour and some other things and the zero conf stuff. But I really don't know why do I run MDN? Because I've had a lot of trouble, maybe related to this, with ESP32's TCP stack, the LWIP and things like that, where I want to set up configuration that seems to be dependent on MDNS, and it works wonderfully as I build it and test it, and then I take it somewhere like Scranton and try to sit there on their network and
well, there you go.
Yeah, and I still haven't figured it out even a little bit. And also under Linux, I have a lot of difficulty. Some of my devices report MDNS .local sorts of names. An MDNS looking, I think that's part of MDNS, looking names to some tools like Angry IP and stuff see them sometimes, but I just reconfigured a PC over there that won't do, absolutely won't do SMB, absolutely won't do, it absolutely doesn't see, won't see my backup server. It won't see anything except the most plain vanilla stuff. And my suspicion is a lot of this is in AVA, how do you say, Avahai or whatever it is. But there's not much out there that's really intelligible about it. Something you either know or you don't, as far as I've been able to find. Has anybody shed any light on that? Why do you run?
All I know is I couldn't get for a while the Orange Pi that I've recently been working on to work until I don't know, I can't even tell you exactly what I did with the AVAHI, however you pronounce that, Avahai, so that it finally recognized the dot locals. So what was happening was Radio D was starting fine. It was creating the sockets, creating the names, and they were not being properly published, I guess, so that anybody else could pick them up. And I don't know why Avahi was installed, and I don't understand it either, though. I'm in the same camp you are, Dave.
Yeah, I mean, I think that they can fight. I think Avahi can fight with the regular DNS service, and the regular DNS servers can pick up the multicast DNS. So there has to be a precedence of DNS servers. If you, it is, I don't know, again, one more reason why multicast is a real problem. And
if I set up all my DNS servers to point to something like Google or one of the big backbone providers DNS, might that explain why I can't see any of this stuff
Yes, I
Um,
would think, yeah, I think you have to
Okay,
use your local,
yes.
you have to have daisy chain, have your local DNS service be the cache for
That would explain a lot of things.
yeah, if you don't.
Perhaps I ought to set up a little DNS server locally. That's mine rather than
Well,
somebody
well,
around.
every Wi-Fi router you buy at Best Buy has a DNS service in it. So
I know it does, but sometimes I can't really see or control it much. And
you absolutely can't control it. Yeah, I know they make it very difficult. So it's
I have a lot of Ubiquity switches and routers that have all kinds of services in them, and things like uh, uh, what's the firewall software? But anyway, lots of things, but I don't always know what to turn on. Yeah, there's so
it's
so many.
when my first attempt to deploy with Phil was at KFS, and where we have an Ubiquity edge switch, decent,
Yeah, so
did nice, very nice device. But
except
and
out
of
of the
course,
box, no.
except
Only do things you don't want.
and it turned out, of course, that IGMP wasn't enabled, and you couldn't get to it through the GUI. That in fact, that the whole IGMP management of it only was available through kind of hidden parts of the CLI. And fortunately, one of my collaborators, Brett Anderson, is a whiz at all that stuff. And we got on with Phil and Brett and me on a Friday night, and an hour later, we had multicast routing around the KFS facility. So it can be done. It's the capabilities, but there's this special version of Ubiquity firmware that has to be put in because the regular stuff is broken. I mean, it is you absolutely need a high priest of routing if you're going to deal with multicast routing. It's
I
just
thought that was Ubiquity in general too.
I think Michael's solution is a very good one. Stick all of the video. I mean, that's how multicast based professional TV systems work. There's a separate control network, and there's a video network, and the video network carries all the multicast traffic and none of the control traffic. And the video, and you have all kinds of protections. There's multicast source routing, so you can it's a wonderful tool. Especially for redundancy. Of course, it's efficient distribution through multicast and the source-based control. So clients can, if a stream disappears, the client can say, "I've been watching the other stream, coming same multicast destination, but coming from a different source. I'm going to start using that," and bam, you can, well, this is, my example is for AT&T's Uver system, which was one of my flagship customers, and yeah, the things on a failure, we'd switch over in milliseconds. You could switch over. So it's great technology, but it's, I think, not appropriate for our applications. So
Well, it does seem like we ought to have enough of the gotchas clear in our heads that when people that we're trying to proselytize this stuff to, which I think a lot of us are.
Well, that's what we
swamp.
Well, what we did is after that first night of pain was that Phil turned the TTL to 0, so that by default the multicast packets do not exit the server, the 9Q server. They're only accessible by a local. So you still have to have Avahi, the multicast DNS service running, but none of the packets get out and they're not communicated to the rest of the network. So you can actually, if you're not trying to run multiple 888s at a site, you don't need a multicast aware router, and it'll be safe. But I'm sorry I arrived late, but I did have a topic I wanted to discuss about the 888 that if there's whatever is the appropriate time.
Yeah.
So probably several topics, but um, I think one is that Michael, I think, had a really frustrating time up there in North Dakota trying to get his remote installation to get rid of all the noise. And I think it failed, right? I don't think you ever really got it working, Michael. That's right. So you brought it back.
I had the Orange Pi plugged in, I mean, powered by a battery, the battery in an unplugged UPS, and nothing else plugged into that UPS. Nothing else plugged into it. So the RX 888 was powered by something else. The Mini Bodnar GPSDO was powered by something else. There was no wired connection to the that would account for ground loop noise, accounting for that. But every 2 minutes, when the CPU spiked, when Whisper Demon did the decodes, it would the noise would go through the roof, and the output stuff would fluctuate wildly all over the place. That was visible in the control panel that KA9Q presents, and I could never get rid of it.
Well, I'm performing an experiment with my Orange Pi to try it. It's out at KFS, and we'll see if it suffers from the same problem. But I did observe a problem at KPH that we were looking at the solar burst, right, that occurred. And Gwen has prepared a one-page presentation on the changes, the ability of various sites to detect the increase in atmospheric noise that occurred when the burst arrived at 1648 or whatever. And in the process, I mean, he has a great paper, and it's good. I think he's put it up on the Whisper Demon technical stage. But it's a wonderful way to look at the quality of different receive sites, because you can tell the change is basically like you have a noise generator, okay? A solar burst. And by looking at the change in background noise level, you can tell how good a site is. At the best of them, Clint's K70EIs had a 20 dB increase during this solar burst from background noise level up to peak. And some sites couldn't see it at all. So, and KPH was decent, but not as good as I would hope. But I think I know some of the reasons there. But in the process, what I observed was that there was a tremendous divergence in spot count between the 888 and the Kiwis. I run a parallel. I have a Kiwi, 14-channel Kiwi, and a 14-channel 888 fed by the same RF off of a passive splitter. Okay, and the spot counts most of the time are almost identical. I mean, they're very close to each other. I mean, within 0.1%. Okay, sometimes one is a little higher than the other. Saturday, starting at 10 a.m., I suddenly saw our RX 888 counts diverge way down below the Kiwi counts. And I know, what happened is that Saturday at 10 a.m., the volunteers come in and turn on the fluorescent lights inside the building until 5 p.m. And during that period, the fluorescent lights these are antique, right? This is a historic radio museum, and the fluorescent lights are from the 80s, and they sure have noisy ballasts. I can hear them on the Kiwi. We can see the noise level go up, but nowhere near as much as it went up on this on the 888. So it seems like the 888, your experience, Michael, and that experience in a pretty well-controlled environment at KPH suggests that the 888, when and that's at KPH, that's plugged into a Ryzen 5, host regular x86 PC. So I don't think this noise problem is solely unique to the Orange Pi. I think that that there is a problem with the RF design of the 888. It may be inherent to the use of USB. I don't know. I mean, I think there's a major amount of investigation that needs to be done to understand this if we're going to create our own version of a 888, because this sensitivity is totally unacceptable. And of course, your experience makes the 888 unusable.
Well, 888 or the Orange Pi. I mean, it was the Orange Pi CPU processes that were it's when the Orange Pi went to 100% CPU cycle that all that stuff popped up.
Well, I mean, but you didn't have another host CPU to compare it against. I mean, you might have, so that's why I say there's a bunch of work to be done to try to identify the noise ingress mechanism in the in the 888 design, and make sure that that ingress mechanism isn't present in any version that we design. But there's so much difference between plugging a SDR into have an antenna feeding it versus sitting it in your lab with, source, signal generators feeding it. It's just a complete difference. So that's, so I will be looking into that, but others, I'm sure, are more expert on this than I, and mitigating RFI and isolating it. And as I say, I'm not sure that it's unique to the Orange Pi as a host. So I was a little alarmed because, of course, I've been recommending to many people that they go, that the 888 is this great platform, and suddenly I'm realizing that, there's a vulnerability to it that I was not aware of previously. But, I mean, it runs very well at several sites, but this, at KPH, the vulnerability was an extra vulnerability to the locally generated in the room RFI, and that's, I need to be able to spend a day out there, which I never get to do, trying to isolate and mitigate the problem. But that's a heads up. And the other thing, and the other thing that I wanted to alert people to is I've recommended to a lot of you and to others that these little mini PCs with the Ryzen 5 are a great platform for Whisper processing and other processing. And it was only on Friday when I loaded up the Ryzen 5 out of KFS and had it processing, 4 antennas with 8 to 14 bands each, running, 35 decode jobs at once, that I noticed that, it was Clint and Brett who pointed out. He said, you may have thermal problems. And sure enough, the mini PC that I got doesn't have any thermal fan control. So the fan was sitting there idling. And so the CPU, even when it was kind of doing very little, was running at 60C. And when you fired up, and go to 100 percent processing for the Whisper Daemon cycle, it would go up to 70C and stop there, and the CPU clock would go down. And it would take forever to process it. So it turns out if you have one of these, I went out today and found that there is a BIOS setting for the fan, and set it to max fan all the time. And I've never seen such a change in PC's performance. The CPU is running at 40C, 40 to 50C. It's getting done with it. The jobs that it couldn't finish in 2 minutes, it's doing it under a minute now. So I'm feeling a lot better about the Ryzen 5 and the mini PC now, but it means that you've got to go into your BIOS and turn up the fan, because you can't depend upon Linux being able to control the fan on that thing. So those are the two subjects. So the B link that I have here and out at KPH is the unit that didn't have the fan control, but I have a different brand here, and I don't think it does fan control under Linux either. They provide it for Windows. The manufacturer provides some kind of mechanism so that Windows can control the fan, but when you're running Linux, it doesn't know how to do it.
So you had to instruct the BIOS just to peg the fan at maximum? Is that the way you did it?
Yeah.
Yeah. Okay.
Yeah. It's really quiet, you know. It probably wear out the fan sooner, of course, but it certainly won't wear out the CPU as quickly, and you'll get a lot more work out of your CPU. So those are
Mike.
Yeah.
Michael, you try to run the USB cable through a toroid with a few loops. That's what I do in my Zygo to get the USB clean. At least seems to help a little bit.
I did not try that. I had sort of packed
You
up
can
the
get a
minimum set
toroid
of
for like
gear thinking it was
$20
going to
on
work.
Amazon.
Yeah, I've actually ordered some toroids, and I'm going to experiment with that and see if that isn't part of the problem. Because the one cable that connected the two things was the USB 3 cable. It was the cable that came with the 888, and so that does remain on the list of suspects. I would say that's on the list of suspects. The power supply feeding the Raspberry Pi is on the list of suspects, and it may be. I think it's within the realm of what Rob was talking about. You can't position the RX 888 that far away from the rest of the gear with the length of the USB cable as it was. So there may just be some noise being generated. There was no other ambient noise, and it seemed to be related to what was happening in the Orange Pi. So
there are
it seemed
tools for tracking these sorts of problems. Like I have just a cheap set right here, but it's based on a little preamplifier. It's often included as part of a high-end spectrum analyzer or something, and but I don't think you need a lot of real fancy stuff, and as long as you've got the right bandwidth. And there's a whole bunch of probes for both near and far field that are little micro antennas. Anyone who probably has done circuit design seriously probably has some of these kind of tools, but they're just specifically for looking for sources of RF noise inside in or around devices. And I think I know where a good article on how to use them is, just for future reference.
All I had up in Fargo was an AM radio, and it didn't do enough to give me anything.
Good start.
It can help sometimes, but it didn't provide any joy. So,
well, yeah, you knew the source. I mean, if it was CPU associated, then it's certainly coming from the Orange Pi.
yeah.
And if you ran it from a USB, I mean, a power supply, battery, that that you certainly eliminated the ground loop. It sounds like you did that. Well, this is stimulating me. I'm tempted to throw a antenna out here, a loop on the ground outside my condo here, hidden in the. I'm next to a creek, so I can throw a loop on the ground out there in the brambles, and nobody will notice. And I thought I might try my Orange Pi out there. Or I might do it out at KPH out on a field where this. So the other,
Speaking of white noise, did you try to build John Melton G0RX program to see if you can see the noise there? Because it'd be interesting to see on his waterfall what it shows, you know,
I would
especially for Michael's
absolutely,
case.
yeah. I just haven't. I've been working 16-hour days, and that's down my list of things to do. It's just
Get
like
towards 17 now.
I need to. I've got two triple eights to modify. One of which is going to go out to um Schwartz. What's his name? John Schwartz out in
Yeah.
out in at to go. We've been working with Glenn to deploy a grape and triple eight Whisper Demon triple eight receive site about, I think it'll be about 2 miles east of WWV out in a farmland. So we're going to try to get that up and running in the next few weeks, so that we have kind of a reference site. I mean, you need that for the grape receivers. We need that for the Whisper Demon grape service as well. And so I'm contributing a 888 and a Think Center, and going to ship that off to him hopefully tomorrow. So, and Glenn is N6GN is offered, I think may contribute an active antenna and maybe a GPS DO to that site. So I got some email from let's see, is it Dave Schwartz who's I haven't
Jay.
W0DIS.
Yeah, Dave Schwartz. And Dave sent me, I'm sorry, I just, there's so many people and sites I'm working with, but he just sent this afternoon, went out and he did a site survey, and he has a friend who owns a greenhouse, which hopefully doesn't have lots of LED grow lights in it. But hopefully it doesn't, in which case it should be a wonderful site out in the country. So hopefully in the next, I guess Dave needs to have this installed and running before the end of this month, because he's got some the health things happening, I guess, planned after that. So this is timely. So we should have that site up and running and contributing grape data. I've also been working with Bill Engelby. Is it Engelkey? How do you pronounce Bill's last name? I stumble with my
Engelkey.
hair. Anglesby, is that right? Okay, well,
Engelkey.
Engelkey.
Yeah.
Okay. Well, anyway, I've been working with Bill. He's got one of those Ryzens and a 888, and between my ambiguity in my installation instructions and installation configurations errors, it's been hard to keep it to get it up and running. But I've been working through all of the It's almost all configuration problems. It's ended up. He put Whisper Demon in a different directory that I'd never put it in, and as a result, things didn't work the way they were. It broke the installation. But when it's running, he has a great rural site there in Alabama. So and it would provide him with the IQ WWV IQ data. I'm still working, Franco, to come up with a site that's running reliably,
Yeah.
so I get a full, uninterrupted and a site and a server that is not being fiddled with by Phil or by me, so that it produces a coherent data stream. But the recordings, when it's running, and not I'm not being interrupted by configuration problems. We are, record 24 hours. I think it's perfectly working. I think our issue there, right, Franco, is I haven't figured out how to do the downsampling from 16 kilosamples
while
down to 10.
Nathaniel is here, there is another issue I want to discuss first is, do we want to just go down to 10, or you think we may need a little more to be able to
Near-field
tell
RF probes or
WWV
sniffer
from
probes such as
WVA?
these can be extremely valuable to help you locate.
Okay.
Sorry about that.
Yeah. So ideally I think we do want a bit more to be able to identify between WWV and WWVH. I think that can be done, say with about two at minimum 2 kilohertz worth of bandwidth, because there's 1,000 and a 1,200 hertz tone that each station sends. So if we had 200 kilohertz, I'm sorry, 2 kilohertz of bandwidth around the carrier, that should give us enough information that there are multiple ways to tell whether you have WWV or WWVH.
So in that case, from 16 to 2, we would have to decimate only by 8. Is that right?
Or you wouldn't go to, no, it'd be 16 to 4. If you want 2 kilohertz bandwidth, you need
No,
4
but
kilohertz
16,
sample. 16 kilosamples gives you 8 kilohertz bandwidth. So if
no,
you
16
need,
is IQ, so you need just to go
oh,
to
it's
2 of IQ.
oh, I see your point. Yes.
Yeah.
Oh, yeah. I forget. This is not
Maybe we want
PCM.
a little bit more than
But-
2.
Yeah. Bill seems
Because-
very concerned about the data storage space. And there was an issue that came up with him that is yet with me and him that is as yet unresolved. He's, by my calculations, and my program generates a 24-hour long 10 sample per second over 24 hours, generates a 3.8 megabyte file, I think it is.
Okay.
Okay.
Per 10.
Well, what's that?
Per frequency. But if you multiply by 10, how many frequencies you are doing actually, Rob?
Well, we're doing all of them, but I'm just looking. I said, well, Tom, I said, what's the? Yeah, he said, well, said each band, each WW time band, recording, 24-hour time band recording is going to be 3.8 megabytes, and he said, and Bill said,
Should be
well,
like
no,
around 35.
he's 35 megabytes of uploads coming from the Grape One digital record DRFs. So there's a factor of 4 difference between I mean, what I create, what Whisper Demon creates is a fourth the size of what's being uploaded by Grape receivers.
Okay.
So I don't understand, the difference between the two, and what's where I'm wrong. I guess I don't, I have a little spreadsheet where I calculate out all of the bits per second, samples per second, and so on, and I come up with that 3.8 megabytes, and that's what SOX creates when I ran the SOX. Now I did the decimation in the crudest way, daisy chaining 2 decimations by 400. But
Rob,
I'm
you
hoping
have 16-bit shorts. What I think Phil has 32 bits floats. So just that is a factor of 2.
we're looking at what's well,
PCM is 16-bit shorts.
Yeah, I know,
I
but
have a
these aren't PCM.
spreadsheet.
These are IQs. These are 2 16-bit PCM. So it's IQ is
right.
So IQ is 4 bytes per sample.
Right, but I think Phil, sorry, Bill was talking about 32-bit floats that he was using, if I remember correctly.
So is that conversion being done before? That would double the size, okay? If that conversion being done before upload?
I
it's
suspect because it does the filtering. So when you do the filter, say you use GNU Radio. GNU Radio does everything in, and Tom, correct me if I'm wrong, in float. So you have a factor of 2 because of that, those fear filters or whatever filter he uses.
yeah. Well, I suggested to Phil, wouldn't it be nice if 9Q would output since his native mode is 32-bit floats. Why doesn't he have an IQ32 mode that outputs 32-bit floats? I multicast those, and then there wouldn't be any conversions involved.
Because
Phil,
is constrained by the RTP protocol. RTP is just done for 16-bit short, because if you think in terms of audio sound, they usually use 32-bit.
Yeah. Well,
here's what we computed, Rob. So,
yeah.
Okay, so this is saying 2 bytes assumes 16-bit sampling. So bandwidth per channel, 0.1. Let's see. Oh, this is 0.1. Why did I say that in kilohertz?
Let me pull out my
hertz.
spreadsheet. Give me a chance to pull out my spreadsheet here and see where I went wrong. So this is probably more educating me against. Here's my grape calcs. Okay, so I say 10 samples per second.
Okay.
All right.
So actually, well, what I have in the spreadsheet right here is I've got
kilohertz.
0.1 kilohertz.
That's
So that's
100.
100 hertz.
That's 100
So
hertz.
and if I do that, I get 33 megabytes a day.
That I
If
can
I do.
yeah, absolutely. That one makes sense to me.
Yeah. If I do,
but
if I do 0.01, that's
no,
the same thing as
no,
that's
that's point.
10. That's 10 hertz, right?
Yeah, that's 10 hertz. Yeah.
So then we're down to 3 megabytes per day.
Okay. So good. Okay. My understanding is correct then. Okay. So that's if you want to, I mean, we're starting with 16 kilohertz. So I just wanted to be sure I wasn't missing something in the processing.
Yeah.
But I think the filters that I didn't, I think Franco clued me in that there's all these options for filtering and decimation. So I could apply any one of the SOX filters, and when I tried to decimate just using the default filtering from 16 kilohertz to 10 hertz, I didn't get the right size files. So what I did was I ended up, and this is a work in progress. I'm writing a grape upload daemon, or as it would be go into Whisper daemon. So because I'm creating the files now, so the question is, how does this upload daemon work? And so I was doing the decimation. This thing would wake up right after UTC 0 and go through get on every band, get together the 1440 minutes of each band will have 1440 minute long files. So I'm using SOX to concatenate them together into one 24-hour file. Okay.
Yeah.
And then once you have the 24 hours, I'm having SOX decimate it down from 16 kilosamples to 10, and that did not work. So I ended up having to do a stage where SOX would take 16 kilohertz down to 400 hertz and create a wave file with 400 hertz sample rate, and then take another a decimation of 40 to go. And so these are two decimations of 40 instead of one decimation of 1600. And that gave me the right size file. I don't know and you took a look at 4 hours of that, right, Nathan?
Right. Yeah. So I have that right here.
Well,
maybe the better question for Bill is why does his 35 megabytes?
Yeah, I could see a reason if the grape client is upconverting or creating the data in 32-bit float format, and
Mhm.
then creating a digital RF upload that's 32-bit floats, that would be
Mhm.
twice the size of the wave files I'm creating.
But that's still only 6 megabytes, not
But that's
35.
yeah, it's not, so it's still off by a factor of 4. So
Yeah.
I don't quite understand that the size of the current grape uploads and why they're that large. I mean, it's not, in either case is a lot of data, but if you wanted to do 2 kilosamples, you're now, to get the WWVH signals, identify it, then you're not talking about, an order of magnitude more
Right.
data.
Right.
The other thing that occurred to me is if you wanted to identify that, I wonder if it wouldn't make more sense to have the processing have Whisper Daemon take a look at the files, and I look for those tones and find those tones before and identify them, and then you could say, oh, my upload script could say this block of time was WWVH because I see the
Mhm.
tone, and he could throw away the rest of it, go back to 10 hertz,
Yeah.
and that would save you a lot of data space.
I completely agree with that. I've been suggesting that for some time now. It's just nobody's done that. But yes, I totally agree. So
It's really easy to do. SOX will give you it will give you a FFT output, and you can go look at the FFT bins from SOX and identify the tones that are
yes,
present.
I've suggested that, and I think that's really the way forward to both minimize the amount of data that we have to save and maximize the amount of science we can do from it. And I think whatever that algorithm is, I think it needs to be able to tell you, do you hear WWV? Do you hear WWVH? Do you hear both? Or do you hear none? So you have to, like maybe when you say, oh, like WWV is 80% strong and VH is 20% strong. So you might be able to actually have some sort of values for those.
When do those tones appear? Are they
yeah, they have here
I'm
I'll
sure
get
I have
a there's a nice website that they have that here I'll put the link in the chat. And it gives you multiple ways of identifying WWV versus WWVH. So there's not just a single method, but this is the WWV and WWVH digital time code and broadcast format page.
Yeah.
You've probably seen this before. Yeah. So you can see, let's see. So here, 12 beginning of each minute identified by a 0.8 second long 1000 hertz tone. So every minute WWV does 1000 hertz tone, where if you look at WWVH, every minute it does a 1200 hertz tone.
And how long does that tone last? Does it
0.8
Yes.
seconds.
Oh, that would be really easy because you can have SOX truncate and look at those at the beginning of each 1 minute file.
Yeah.
And do you don't have to process the most of the file. You can just look at the first 0.8 of a second and get an FFT off of it and take a look at what the FFT bins and see what's there. That's not hard to do.
I mean, if you can implement that, that would be.
Oh yeah, I could implement that if I can get the filtering to work. If I don't understand the filter options, so I don't know the side effects of the filters that I'm applying. So if you or anyone in the group who has insight into the signal processing, the side effects, the aliasing or other distortions introduced by the SOX processing, and help me come up with a 1600 to 10, 16,000 to 10 kilohertz that results in
the main
decent quality. But that
the
was
main
why I wanted you to look at it. You know,
yeah.
so.
The main thing that you want to do with the filtering is that before you decimate something, you need to low pass filter it, low pass filter the full rate thing to a bandwidth that will fit within your decimation.
Well, I assume that SOX does that, though. I mean,
Yeah.
again, I'm
But
a
I'm
neophyte
not,
user of,
yeah. So, but that's the rule. So like, let's
Yeah.
say you're going, let's say you have something that where you're sampling at a 10 kilohertz bandwidth. Okay.
Yeah.
And then you want to reduce the bandwidth to 5 kilohertz. You can't just go
Yeah.
decimate it. You have to first apply a low pass filter that
Yeah.
will give you a
L-
5
l-
kilohertz bandwidth, and then you
Yeah.
can decimate it.
Yeah.
That's
It's
the main rule.
it's the reason we put
Yeah.
the 30 megahertz low pass filters in front of our
Yes.
SDR.
Yeah, it's an anti-aliasing filter.
It's
Yes.
anti-aliasing. Well, my assumption is that SOX does that when I tell it to change the rate. But there
I
are
don't.
many, seems to be many options to the how of filter options. I
Yeah.
used only the default one when I did my decimation, and I couldn't tell from the waveform, looking at the resulting 10 waveform. I couldn't, in Audacity, I couldn't really tell if there was aliasing going on in that, and it might be impossible to actually tell.
Right. Well, if you
or-
once you make these spectrograms, you can start seeing the aliasing. I can show you an
Okay.
example. So
Yeah.
from the Grape 2, Kung sent me the very first spectrogram from the Grape 2 today, where I could kind of identify something. And it has, I think there are we're doing some funny things there, and I think it has some aliasing issues. And where did it go? Okay, well, that's the first one. But when you have the aliasing, oh yeah, so like here, you just see multiple copies of the same thing at multiple frequencies. And
yes, of course. So that's clear. You can see the sidebands up here. Yeah.
So like I don't see that. I see like some very faint like harmonics here, but I don't see like really strong
You don't see anything. You don't
copies.
see anything. You don't see anything bad. Is this the one we're looking at the one I gave you?
Yeah, this was the very first one, the 6 hours, I guess.
Yeah.
I haven't had a chance to do anything with any of the others that
Okay.
you've made. But if you're able to generate, if you're able to generate these sorts of spectrograms on a daily basis, then it's very easy to kind of see like expected signatures.
Yeah.
So here's the.
Hey Rob, what are you storing on my machine right now? You set it up to be storing IQ.
Yeah, we're storing IQs on your machine. If it's running there, you're probably the best site right now because you probably your system is running probably undisturbed by me or Phil. It's been the problem at all the other sites is so you're probably be a great source of that. It would be yeah, what I was doing was I have the beginnings of the grape daemon, whisper demon, grape daemon, and so I can run it from the command line, and it goes and creates these 24-hour long wave files. So I can do that on your machine, but I'd like to. I was hoping to finish that daemon so it could become a standard part of the whisper demon protocol, and you could just enable it, and it would upload it into those directories that you saw. I created a grape account on the whisperdemon.org server, and that's where all of these will go.
So Rob, if you what I'm hoping you can make is these spectrograms every day. So this is a
Oh,
24
yes,
hour
yeah, yeah,
spectrogram.
yeah. Well,
Because once as soon as you do that, then it's very easy to see okay, yeah, here's night, here's dawn, here's
yeah,
the eclipse, so you're not going to have that, and then
yeah,
there's dusk, and it makes
yeah,
it very easy to kind of troubleshoot and see the science. And if you're Gwyn Griffiths, then you also notice very small
yeah.
offsets from the center frequency. But I think getting this sort of view of the data is going to be incredibly helpful for knowing if you're
Okay.
doing things right or not.
Well, it's it just keeps getting my
Yeah.
working on the grape daemon gets preempted by various crises in
Yeah.
the whisper demon world. So,
Oh, I understand. Like every time I go to my email box, there's another, this needs to be done right away. I'm like, I was planning on working on this code right now. I'm supposed to be doing this thing. But no,
yeah.
this has to happen right now.
Right now,
Okay.
yeah, that's I'm in and that's exactly my situation,
But
and
yeah, but I
and
do have
and I'm really excited to have Bill's,
yeah,
at Bill's site, and to have Michael, site, and
yeah,
I'm trying to get KPH and KFS up, um, and each one of these is it's still a learning experience. Took us oh it took us 4 years to winnow out all the problems with deploying with Kiwis. So
yeah.
I'm not surprised that it doesn't surprise me that it's taken this long. Almost we're going to approach a year getting the AAA into a deployable format.
But I think, Rob, so this is the Jupyter Lab notebook that I sent the other day, and I can put this in the
Mm-hmm.
chat the other day. So this is up on
Mm-hmm.
GitHub.
Mm-hmm.
And where is it? So there, I'm putting that in the chat. And if you concatenate those wave files together, this should give you the spectrogram. So you can then run, download this as a Python script, and then you could just run it in a cron job every evening, and it
I
will
can
give you
okay. I give you those. Well, I do a similar thing for the background noise levels for Whisper Demon. We run a Python script that does the analysis on each 2-minute whisper cycle, analyzes the background noise levels, and I run that every 2 minutes. This what you're doing for Grape is easy. It's once a day. It's not, although
yeah.
it's computationally. Well, it took a while to get the decimation to work.
Yeah.
I kind of I would prefer if I could decimate, find out how socks can go all the way from 16 to 10,
Yeah.
16 killers to 10, because I'm a little uncomfortable with the fact that I'm concatenating these decimations.
Yeah, I think that's I think that's a really smart thing to do.
Yeah.
And I do think I don't know socks very well. I think Jonathan might know socks better than I do. But of course I would suggest reading the documentation, and when you look at
If you look at socks, it is a Swiss Army knife of audio processing.
It's a
Yeah.
It
very
can
powerful.
it's incredibly powerful. You can do all kinds of stuff with it. So
But
it's
they must.
something-
So I mean, they obviously they have to have the right recipe for properly doing the decimation. It's
oh
just
yeah, because this is used in professional audio, for audio recording and for
yeah,
manipulating audio files for commercial recordings. So
mm,
it does, they all kinds of anti-echo effects you can apply. There's amazing number of effects that are available to you. So I'm asking Socks to do only a very almost the simplest of procedures.
mm,
Yeah, but it's just one more thing to learn. How that
yes,
is. It's just
yes. Oh, I
you
do.
know, I mean, it's all nothing is particularly hard, like multicast DNS, probably if you could spend 2 weeks and have a mentor, you'll probably figure it all out. But
Yeah,
who's available to mentor you to do that? And I
I
don't know,
know.
I don't have a SOX mentor.
Yeah,
So I end up blundering around using their, I mean, the man page for SOX must be 40 pages. I mean, it's
yeah,
on and on and on and on. So
yeah,
so that's why but I think it's capable of doing what we want to. I think, anyway, your results for the 6-hour result that you just were showing suggests that, at least as a start, the way I'm processing it now is useful, and I should finish getting these
yes,
up every day and not worry about the filtering. And we can
yes,
worry about the filtering later.
yes. I agree with that. This is
Okay.
definitely just looking
Okay.
at these 6 hours. It looks like this probably is seeing what we want to see.
Good. Well, you'll have, you're going to have 10 time bands.
Yeah.
It does CHU 3, 7, and 14, and including all the WWVs, including WWVB.
Mm-hmm.
So, and I'm sure that we'll be able to get, at Dave Schwartz's, I'm sure that site will have a very strong WWV.
Yeah.
So, anyway, but I need to get that, that's ahead of working on the grape, Damon. So,
Yeah.
I gotta
Yeah.
get that hardware out where we don't have
I know.
anything.
I
So
know.
that's where I'm at. Okay, well,
Yeah.
I bent your ear, but I'm glad we got to talk about this.
Yeah.
Michael, I hope we can help you. You might want to wait on using the Orange Pi. I will be doing some investigations on it myself, both initially out at KFS in Iraq, alongside of the other the Kiwis.
I'm fiddling with mine too, and I've got a B-Link on the way. I'm going back up to my mom's house in February if she's having her 90th birthday. So
Okay.
I'm going to, if I can get this all squared away, maybe I'll be able to bring up a working kit at that time. So,
Well, that's good. Well, it'll be interesting. It seems like you could try it out outdoors at your place before you go up
yes,
there and try it outdoors at hers.
that's
So
right. That's what I
yeah,
intend to do. Make sure that
yeah,
I get all these kinks ironed out the way I
yeah.
didn't do this time before I get up there and conjure them
Yeah.
also.
This is the challenge of deployments is see, I wanted to make sure that I still have that I have access, because now that you reminded me, I mean, who else is I think I think John Ackerman has a site that would be good for gathering IQ data. And Dave has one. AV0OS should be able to. He's near you, right? Michael, you and Dave
Yeah,
are near each other.
we're 15 miles apart, as is
Yeah,
Dave Witten there. So
yeah, yeah.
three of
So I
us.
mean, by the way, among the three of you, I do intend to. I want to, again. Here's another one of my backed up tasks, because I have two whisper songs that I want to send out. And I just
Well, that's
wanted to.
another. I'm wondering whether you think one of the things we were just talking about informally was what would be a good site for one of those. And,
Yeah.
I live somewhat out in the country. Dave and Dave both live in town. Dave has a farm. I've got a friend who has a farm, and my mom lives up in Fargo. Now, mom is in town, but it's Fargo, which
Yeah.
is relatively underrepresented in terms of geography for Whisper, and for any of these sort of monitoring sites for that matter. So
Well,
the other thought
the
occurred to me
receive
was,
site, yeah, the receive site. I think you're sound like the best candidate. I haven't really looked at your noise graphs and studied your site, the performance, but let's see. I think I configured you to upload noise graphs, and those are always good starting point to see the quality of receive site. But I think that the urban sites would be better suited for transmitting.
Yeah.
So if you can put up if you can put up an end fed, 130 foot long end fed that does 80 through 10, then the whisper sound can feed that and transmit on all of the bands simultaneously. I don't know, Dave. Dave, if either of the Daves have enough space for that, or maybe you already have a multi-band vertical. If you have a,
I have a multi-band vertical that I think I would move into town, to one of their sites.
That would be an excellent choice too. Those are the two options. The end fed half wave, 80-meter half wave, or a vertical,
Yeah.
multi-band vertical. But I'm ready to send it to you. It's just that one of the things I want to do is calibrate the receive system to make sure that while I have the transmitters here and I have the GPS disciplined receivers here, that in fact that I get the spreading numbers that I expect, which are 8 millihertz, and I just haven't had the chance. I'm not the few minutes I've had to look at that. I got more like I was getting 11 and 14 and 16 millihertz, and I want to be sure that suggests to me that there might be some problems in Ryan Tobin's implementation of the spreading algorithm. And so I was comparing the spreading numbers that was coming from his Whisper decoder with the JT9 spreading numbers, but it turns out that those are wrong too. It turns out he uncovered a bug in the JT9 reports on spreading. So I need to build a special version of JT9 that incorporates his fixes, as well as his special version of Whisper Daemon, get them of Whisper D decoder, and see if they should agree. If I have two transmitters that are one transmitting FT8, FSD4W, and one transmitting Whisper. They're both GPS disciplined by the same clock. So the spreading numbers for them should be almost identical. There's very slight differences in the bin sizes, frequency bin sizes between the two Whisper and they have few. I don't know which one. One of them has a fewer symbols in 2 minutes, so the slightly different bin sizes, but they're both 8.3, 8.4 millihertz is the frequency bin size that should be the resolution and presumably the accuracy of the reports from the system, and I'm not getting those. So it's hard, I want to send out a calibrated system, and I haven't had the time to do the calibration. So, and of course, if I find a problem, I need to figure out, okay, we can ship it out, and I think that the problems are. I'm pretty certain of the Whisper sound's accuracy. It's Paul Elliott's very good at calculating the frequencies down to the millihertz for his tones. So I really doubt that there's a problem on the transmit side. But so I may just send it off and then use my QDXs. But then I worry about the QDX because if I use the QDX as a reference source, then I have an audio problem, and we've uncovered there's serious. Gwen has identified that the audio recordings can be 100 millihertz off. That because there's these clocks in the audio sections of PCs and these dongles are so uncalibrated, and so he's very Gwen is confused and concerned by the use of uncalibrated audio sound cards in the grape recording process. And I don't know that you do any calibration on grape sites. But
I don't think we do. Well, I know that we don't do any calibration right now. I know that one of the concerns that Gwen had regarding this frequency offset. There was a side conversation we had with Bill Engelke, and I think that resolved some of the issues.
Yes, I think Bill said, well, that was a little
early
thing that he
version
threw
of the
together,
code.
early
Yeah.
version of his code. So he said that but then the raw data was the stuff that was off.
No,
But
the two plots were coming from the same raw data, so it's not like it was additionally processed.
No. But he said the raw data showed
Yeah.
a 100 millihertz offset.
No,
And
that I don't think that's entirely true, because I can show you what he was
okay, maybe
looking at.
Yeah.
And because at least my understanding of it, frequency offset, where'd that plot go?
This is Bill on the grape too.
Bill Engelke.
Oh, Bill Engelke. Okay.
Yeah. So I think, come on. There's one email from him when offset. Where did the other one?
Yeah. Well, I know that Gwen showed up on the Thursday morning call just in order to pursue this, and I know that he's in conversation with Bill Engelke on this. So I don't think I'm may be just adding confusion here. I'm sure that Gwen will report what he learns.
Okay, I found what he had sent me, and what I think. So here's my understanding of it. My understanding is that he looked at these two plots.
Yes.
Okay.
That's right.
And he said that
the upper one is he thought was the raw data from the grape database. And
the upper one.
Yeah, and that's the one that shows the offset.
Yeah, so this is a view of the raw data, but this is also supposed to be view of the raw data. So I think this is where
okay,
I think it
I think that has been resolved.
I think
that difference was resolved, and it was Bill admitted that it was probably an imperfection in his generating the lower. But there remains the question of why is the upper raw data offset over a long period of time, offset by 100 millihertz? That appears to be now maybe that's not. Maybe all you really care about is that as long as it's stable, you don't really care that it's offset. But okay, that might be the right answer, but I think that's what he observed, was that there was this long-term offset, and that suggests that.
Yeah, I think for now that's the right answer.
Yeah.
I don't think forever that will be the right answer, but I think for now that's the right answer.
Well, I think I hope that you won't see that kind of offset from the Whisper Demon Grape feeds. That they're all GPS derived, so they should be.
I mean, it's tricky right now with the grape because they're putting so much. They're really working on the grape 2 right now, so the grape 1's kind of like frozen at the moment, and then so it's.
But is the grape 2 using depending upon the sound card of the host PC in the same way?
No, they have a different ADC in there.
Oh, okay. That's a good thing then.
Yes.
That would eliminate the PC sound card as a
as
a source of errors.
That's right. That will not be in there.
Okay, good. Well, in any case, okay. Well, I really appreciate the ability to talk to all you guys about this and help me with my problems. And
thank you very much too.
Well, see, I wanted to look, Michael, before we leave. Let me just be. I always want to be sure if I can hear. Your remote access channel is. That's. Well, you have 2 of them, right? You have 2. Probably don't need both of them, but you're. Oh yeah, it's your
Well,
27.
there's 3,
Well, yeah, there's a North Dakota.
but that's not active now. And then
That's,
there's
yeah,
2
but
machines, 2
yeah, there's
different
too much.
RX 888s.
Yeah.
Um,
But
2
one
different
is feeding the other.
antennas.
One is really acting only as a triple eight, and its output is going across your land to your I-5
Right,
1340, which is really your Whisper Demon machine. This is
right.
let's see. Let me be sure. Let's see what. Oh yeah. Oh yeah, you got old code though. Okay, I'm going to upgrade the code on your machine so that it creates the FLAC files in the appropriate format, and I'll okay, so we need to do that, and I'll just flush all the FLAC files that are there. They're good, but we'd have to sort them into individual days. I'm not sure it's worth the trouble. I don't have time to write a script to do that, and you know, but
Yeah.
yeah, I'll put a newer version of Whisper Daemon that creates a directory tree. So the root of the wave of the tree is a day, and then underneath it is the site and the receiver and the bands. And then in each band, will be 1,440 1-minute long flat compressed wave files. Right now, you have a single directory that has
That's all of them in there. Yeah.
all of them in it. Has 23,000 files in one directory that are that were so that's how many you've how many you've, let's see, the most recent of course being the 8th at 21:57. Let's see, that's local time from the 5th. This is almost a month's worth of great recordings, but it's not in a format that'd be used, although it's awfully good to have it there. It'd be really interesting to, maybe I shouldn't toss this stuff, because it's pretty unique set of recordings, and in the midst of it is the solar flare, and maybe I'll how much of the
Yeah.
disk space is being used. Let's see how much.
The solar flare is in there.
Yeah, I know.
Yeah.
It's a solar flare is a. Yeah, you're using a terabyte of your 1.8 terabyte drive. I'm sure it's all. Let's see, DU/SH. See how much is.
Well, I can copy that over to another local drive just for storage, and then leave the rest of it for the properly formatted stuff.
That would be it would be very good. You have 7 terabytes of FLAC data that includes some pretty unique events that these files are completely compatible. Well, let's see. Are they telling me? Actually, they're not going to be. Oh yeah, I remember. Oh yes. Oh yeah. Oh, this would be hard because I'd have to untar each of these and sort out the stuff by bands. It would be. I don't know if you have a spare USB external drive, plug it in and I'll copy the data over there before because it might be some pretty unique data. So
Yeah, I think I can move that over. Okay.
Yeah. Okay. Good, but I'll send you an email when I've changed it. Probably not tonight. I'm kind of burned out today, so I'm not gonna.
Yeah. Okay.
I could make some mistakes, and then we'd have to talk again. So to get you back online, but your system has been what? This system has been up for 12 days. You had an outage. Your i5? Did you lose power there 12 days ago?
I don't know. I was out of town.
I think you did.
But
I think you had a power outage.
okay.
At
Came back up
which
though.
point? Yeah. Oh yes. Everything. Whisper Demon went is properly installed, it comes up right away and everything runs, but it means that there will be a gap in the recordings of a day. And I'm not sure how to deal with those. Maybe, I was just going to throw them away, but I could put in, silenced wave files, Nathaniel, on those recordings if there's, minutes or hours missing. And maybe they'd still be useful to you. Because everybody's going to have reliability of their site problems. It won't be.
Oh yeah, if the site's just not recording, I guess the thing, yeah, somehow show that there's no data, either all zeros or.
I don't think it'd be good to replicate 1 minute recording until another one comes along. I think you should put in I'll put in a 1 minute of silence if there's a missing minute.
Okay.
For each missing minute, I'd put in 1 minute of silence. But
Okay.
I do a lot right now to enforce with the new software that I've written for K9Q. I do a lot to ensure that there are exactly 1,440 files, each of which has exactly 960,000 samples in it.
Yeah.
So that this is, phase coherent with the GPS DO that's clocking the 888.
Right. There's no way in a wave file to make not a number, right?
What do you mean?
So when I'm in Python, there's a symbol instead of like a 0, I can put in the not number, an NAN.
Oh, yeah. I don't. These are PCM wave files, so that they're just simple 16-bit, signed integers, and so there's, but to see a whole file, wave file that had 16 a minute, right, of zeros would clearly be an indicator that this is an error. It's not even like the antenna was disconnected, because if even with no antenna, there'll be some noise.
Yes.
So there will be non-zero samples in the wave file. But if there's a failure of the whole system and power goes off, then I think that we could identify those events pretty easily by just having the wave files be off. Okay, so I think that's a reasonable strategy. Otherwise we have to, there's
right.
I mean,
I agree with that.
Okay. Well, I don't. So that's. Okay. Well, I think Franco, who's left us, I think is once I get this up and running, I think Franco will work with Bill, and even Bill seems to be interested in this now. Now that he has his own source of Whisper Demon Grape files, I think he'll be. I think he'll be engaged in trying to get that data into his Grape database. So it's
I totally agree with that.
Okay. Anyway, that's my area that's what I'm focusing on right now. So
yeah. And I think getting the data into that Grape database is going to be really important, because in terms of our science analysis afterward, I'm going to tell our PhD student, Rachel, I'm going to say, Rachel, all the data you need is on this server.
Well, that's that's why I've warned you. I don't know how many sites are contributing, but I can put this software into easily into 24 sites.
If we really can effectively get the data down to 3 megabytes a day, and if we can come up with that algorithm to detect WWV versus WWVH, then I think that's very reasonable.
Yeah. Well, remember that's 3 megabytes, 3.8 megabytes per band per day. So if you want to have,
which is still less, that's still less than what.
Yes. Oh, yes. Yes. I say so. If you were if you wanted to save away all 10 time stations,
Yeah.
Okay, you're talking about 40 megabytes per day.
Yeah. Yeah.
And but that's
And
not very
that's
much.
also, and that's uncompressed.
That's right. It would you compress it down, it should be half that size.
Yeah.
So but it is a kind of a shame that digital RF does its processing in 32-bit floats, because it's kind of unnecessary in
Yeah.
our world. There's you got 100 dB dynamic range with
So
with 16.
I did mention this to Jonathan, before.
Yeah.
The reason I picked the reason digital RF is because the MIT Haystack Observatory designed it and is using it for radio science purposes.
Yes.
And so I believe that if it was good enough for MIT and their radio observatory, it was good enough for us.
Well,
But
and I think it would also lower the barrier to have them take a look at the data.
yes.
If it's in a format that they're familiar
Right.
with, and yeah,
So
I agree
that's
with you.
why, yeah, I mean that's why I made that decision.
No, I think you made the right decision.
Okay.
It just doubles the storage requirements that beyond, but storage is cheap, I mean, that's,
yes,
you should,
that is something you can buy. Yeah.
yeah.
So, but
if
I am also, yeah, I would in the future, like once all this kind of shakes out a little bit, we could always reevaluate if we really want to keep using digital RF in the future, or if there's something that's a little more, because digital RF has some issues too from an amateur standpoint.
Yeah.
It breaks up, like every minute is just broken up into like 1 second files in HDF5. It's complicated for someone who's not a digital RF user to use.
Yeah.
So
Yeah.
there, I mean, I think we should just keep, we should all kind of get used to this and then see if there's a smarter way, or if this really is the way we want to keep going in the future.
That's the way scientific research goes. Engineering work, you get something working, and then you see what you want to do next and how could improve it. But
yeah.
Okay.
Okay.
Anyway,
Great.
I wanted to I have two whisper songs just to veer off the topic. One of them is going to go to Michael and Dave's in Missouri.
Good.
I think that there was a fellow down in Texas who hasn't been participating, who in one call mentioned he'd host it. But
Was it Steve Serwin?
Yeah, probably was Steve Serwin. Yeah, that's
Okay,
right.
yeah.
I think. Is Steve? We haven't seen him for a while. I haven't, at least.
Oh, he's very active.
Okay.
He just
Okay. Well,
he's doing some other things besides the grape, but he's extremely active.
Okay. Well, I wanted to take him up on his offer, because I think that
I think he'd have a good site.
Yeah, and it sounded like he'd have a good site. And Paul is building some Whisper Sound 8s that could be available. So somebody, it would be good to have a few more transmitters along the path.
Yeah.
So I don't how close are you to the path of there in Pennsylvania?
I'm a couple 100 miles away.
Yeah.
Cleveland, Case Western is right underneath it.
Okay, so maybe I should talk to on Thursday. I could talk to Gary about having them host one. I might be able to. I have friends in Rochester.
Yeah.
And who might be open. Jim Lill. I don't know if you know Jim.
I don't think so.
Okay, that WA2 ZKD is he's a good guy. That's anyway, and somebody up in New Hampshire,
Yeah.
Or Newfoundland. I think Gwen reached out to the university in Newfoundland, but didn't get any response from their engineering department.
If you do talk to Gary is keeping a list of all like the people who are fielding the grape locations. And so he has a database of people who want to host things.
Oh, good. Okay.
So you can talk to Gary, and he might be able to help you find a good spot or spots along the path.
Good. Okay. Well, the most important thing apart from location, is interest. Somebody has to be, be interested
Yeah.
in doing this. That's the,
Yeah.
okay, well, it's getting late for you guys, I'm sure, especially
Yeah,
for
it's
you. Okay.
11:15.
Well,
So
yeah, okay. Well, and yeah, so you need to go and get your rest and
definitely.
yeah.
Well, thank you very
Okay.
much. I appreciate it.
Oh, no, thank you. I appreciate it. This has been a life-changing project for me. So I'm having it's
And
just
it was
am,
great.
As we
It was
speak, I'm
great
copying
seeing
all
the.
those files, by the way.
What's that? You're copying all
As
the
we
files?
speak, they're all
Oh,
getting
good.
copied over to
Okay.
a
Okay.
network server. So
Okay. Once
they,
that,
that should be,
would you delete those files once they're over there? And
yep, will do.
and then that'll let me know that I can do a software upgrade on your site, Michael. So that's that.
Very good. Yep.
Great. Okay. Well, thank you all. It's a pleasure to talk with you all. And
Yep.
and see some of you maybe later in the week and others, I guess, next Monday night.
And I will
tend to
not.
come a
I will stop the
Yeah.
recording.